Now in this 2021 paper 1 question 36 MCQ, the four options here are quite similar. They are all parallel circuit. The EMF are all 6 volt, and in each branches there are 2 resistors. Now let's go through the easy method, because no matter what is an MCQ question, you want to solve it fast. Alright, I'll teach you an easy method. Let's start with option A. Now one shortcut that I hope you know by now is that when 2 resistors are connected in series, so the bigger the R, in this case 10 ohms is greater than 5 ohms, the bigger the R, the bigger the potential difference across it. Let's give it a value. Let's say it's 4 volt and this is 2 volt. So this will be 4 volt, this will be 2 volt, because as you know, if it's parallel circuit and happens to be parallel to the EMF, so the potential difference across each branch may be here or here will be 6 volt. Now you may be wondering, how do I actually get 4 volt and 2 volt? Okay, for now, later I'll show you exactly how you get the values, but for now, because it's an MCQ, like I said, I want to do it fast, you understand that the bigger the R, the bigger the V. So you give it an imaginary number. So 4 here, it must be 2 here. Likewise for these two sides. Now, so whenever you look at the parallel branches like that and both sides, and if you consider conventional current, the current is flowing through both branches identically, because it will pass through the 10 ohms first, followed by the 5 ohms. And if you look at the side by side, if here is 4 volt and here is identical 4 volt, there will not be any potential difference across P and Q, so it must be 0 volt. So that's not the answer. So now let's take a look at option B. So if you understand, if here is 2 volt, this must be 4 volt. Let's say you just give it an imaginary number. So once again, the side by side, both are identical. That means to say the potential difference across 2 will be 0. P and Q will be 0. Now option C is slightly different. The branches, in this branch, both resistors are identical, but they are 10 ohms, and the other branch here is in series, but it's 5 ohms, 5 ohms. So, but of course this is basic. You should know that since they are identical, 10 ohms and 10 ohms, each one will take 3 volt, 3 volt. Likewise for the 5 ohms resistance, even though 10 ohms is greater than 5 ohms. So please don't make a mistake there. So once again, so side by side, the potential difference is 3 volt, 3 volt. They are identical, just like these two options. So there won't be any potential difference across P and Q. So that's the fast way of doing it. And obviously the answer must be D. So if this is 2 volt, this must be 4 volt, and then this must be 4 volt, and this must be 2 volt. All right. So if you look at this, the potential difference across these two resistors are different. So there must be a potential difference across P and Q. The voltage will be different. So D will be the answer. So if you use this method, you can straight away get the answer fast, but some students may not understand and they think that this is just memorizing. So now let's go through how you actually get the value. Firstly, let's talk about how do you get 4 and 2. Now, let's go through a method which is slightly longer, but everyone must know, especially, combined science, you need kind of learn this method. So in each branch, let's consider the branch here, the total resistance will be 10 plus 5, that will be 15 ohms. Then I find the current flowing through each branch. It will be V over R, 6 volt divided by 15, 0.4 ampere. Then you can go ahead to find the potential difference across the 10 ohms resistance. I times R, 0.4 times 10, that will be 4 volt. That's how you get it. Then of course the 5 ohms resistor will be 0.4 times 5, and you'll get 2 volt. Or because both are connected in series, the sum of potential difference must be 6, so you can take 6 minus 4, you'll get 2. So this method is something that all of you must know. But if you are pure physics, because you learn potential divider, all right, that concept can help you. So even combined science, I mean, it's good to know this, it's faster. So if I want to find the potential difference across the 10 ohm resistor, it's like you're asking what fraction of the total 6 volt is taken up by the 10 ohms resistor. So because it's a direct proportion, remember I said the bigger the R, the bigger the V. So across the 10 ohm resistor, I'll put the 10 at the numerator, and the denominator will be, it's like the total units 10 plus 5, so it will be 15, and straight away you'll get 4 volt. So likewise, if I want to find the potential difference across the 5 ohms resistor, so it will be 5 over total units 15 times 6, and you'll get 2 volt. So this is in a way much faster. Now the last part here, we're going to go through the true understanding of the DC circuit. Especially if I were to ask you what is the potential difference across P and Q, what's the value? All right, now as in the class I mentioned before, the circuit is like a river system. If it's a 6 volt EMF, it's like a pump pumping water from ground 0 volt all the way to 6 volt. And if it's just copper wire, we can treat it as there's no drop in the voltage, there's no drop in the height of the river. So until this point here, it will be 6 meters, 6 volt. Every time it passes through a resistor or component, let it be bulk or fixed resistor, there's a height drop, there's a voltage drop. And this potential difference that you are familiar with actually give you the height drop, the voltage drop. It will drop by 4 volt or 4 meters. So we start off with 6 here. After drop by 4 meter, this portion here will be 2 meters, 2 volt or 2 meters. That river will be 2 meters. Then followed by here, because it's ground 0, every point here will be ground 0 volt, 0 meters. So the other branch, it will be the same, drop by 4 volt. So this will be 2 volt or 2 meters. The river then finally drop to 0. So if you look at it carefully, the part of the river here is 2 meter, the part of the river here is 2 meter. If you put a voltmeter to measure the difference, the height difference, 2 minus 2 is 0. Or the voltage here is 2 volt, the voltage here on this side of the river Q is 2 volt. So there's no voltage difference, that's why there will not be, it will be 0 volt, no potential difference. So that's how you get. So it's the same thing for here, 6, 0, here is 6. But here there's a potential difference across the 5 ohms resistor is 2 volt. That means there's a drop in height of 2 meters. So at point P, that will be 4. At point Q, that will be 4. Then followed by 0, 0. Once again, it's 4 volt here, 4 volt here. There's no voltage difference. So you put a voltmeter there. Across these 2 points, it can't detect any difference. So it will be 0 volt. Alright, so likewise for C, so the difference here is 6, you drop by 3, then here will be 3 volt, here will be 3 volt. So once again, there's no 3 volt, there's no potential difference, there's no height difference between the two rivers at point P and Q. So let's left with option D. So this is 6 after a voltage drop of 4 volt. Alright, so that it will be 2 volt over here, then followed by 0. Likewise, you start off with 6 meter river, 6 volt. After a potential difference, a voltage drop of 2 volt, it will become 4 volt over here, or the river is at 4 meters. Alright, so if you put a voltmeter across P and Q, there is a voltage difference. Okay, and the volt value, the potential difference is 4 minus 2, it will be 2 volt, or the river, there's a 2 meters height in difference. So that's actually the true meaning of it, and hopefully you understand now. Thank you.